of us. Of course, we met Howard in the symposium in Kenya last year and before, but especially last year, he showed me some magic trick, and I forgot one of them. But so I was really hoping to meet him this week, right here, for the reminder. But it is what it is, maybe. Uh,
Thanks for
the
reminding me,
next time.
Alex, and I'll show you the trick at the end if you remember which one it was.
Yeah. Okay, yeah, sure, sure. And thanks, Ed, for supporting us. I welcome everyone. It's this will be okay. Maybe just to add a few things about myself. I'm also from Murang'a County in Kenya. So, and part of the first service there, and I enjoy and have great respect for my fellow firefighters and Kenyan abroad. And so I feel at home with me, just one among you, and especially proud and happy to share credible information with us. Uh, feel free to put anything in the chats, or yeah, just to say it, so that we have a common classroom. The unfair bit about the Zoom call is that I can see you right here. I can see you maybe taking notes, or maybe for those on video, I could see you smiling back. And I can see somebody in the kitchen actually. It's
What,
those with the video on, but it's okay, no problem. Yeah. Um,
Alex? We can't see your PowerPoint yet.
yes, I'm here to put it on.
Oh, okay.
Yes, I'm about to. So we will be having a conversation about building construction, and this somehow builds right from where where um let me get to it. This actually, it's a good place to build from where Mike Cole left us last week. Mike was um, uh, just a moment. I remember Mike was talking about he was talking about synthesizer last week, and of course, credibly so. Uh, it was a very informative session, I must say, and like this will be good. Let me see. Yes. Mic check 1 2. Yes. So Mike shared about um, um, Synthesize Up, and of course, Synthesize Up is very critical for. Actually, it's a good. Some of the things we do in firefighting, they are just so good for life. Everything about life. If you can make as good decisions as much as you have good information about something. Even if you are to solve any problem or take care of anything, if you have the sufficient information about it. And I once shared a situation with some engineering friends, and they said that if you find a problem, well, you are likely to get the solution. The solution presents itself. It's the same. If we can learn to maybe have good information about the problems, including the fire scenes that we go to attend to, it is also very possible that we would make an accurate action plan that, of course, would lead us to having good results. And that is part of the reason why it's important for firefighters, even if you're not in construction industry, to understand some of the basics and backgrounds. This will not be an engineering lesson or something about construction, really, how to build, but just to sensitize us on some of the key factors about buildings and how they're constructed and how it affects our work. What are some of kind of the risks that we would face from a particular kind of structure? What threats does it pose to us and even the occupants? What are some of the key things to probably see the checkout, so that we are assured that we are making a formidable plan that will give the correct results? Uh, People in the waiting room, I guess someone could let them in. Um, so I wish we had we were in a position to just converse, but maybe just look at the screen and maybe mention, probably assuming this is not your house, of course, but you visited this place, and it's that picture on the screen, and think of if you would, as a firefighter, just see this house. What do you see? What really do you see? And then what does it speak to you as a human being? Like for me, this is a beautiful structure. I like everything about it. I love how natural wood looks. Um, and I want you to critique it like also a firefighter, first responder, and think about also what could that mean to you, especially the firefighter, just as it is. And as we do that, I'm going to buy backup internet because my computer notifies me that my internet could be unstable. I'll get some more on my phone. As you just think about this house, and you can type on the chat what do you think about the house. Maybe I would even ask you personally, would you build such a house? If it was your house, how would you protect it? What do you think would be important? Uh, like such critical information. Then, even as you think about this, I want you also to think about maybe your house back home or the neighborhood or the fire station that you have. And think of how is it built? What is it built of? What is inside the house? Does it have any implications on fire safety? And that would be good to know. So I finally have my internet on, and I'm going to just um, I put it out there for my laptop to use. Yes. Okay. So this is what we're going to look at today. Like we're going to see a few facts about occupancy classifications and how they affect fire suppression, how the contents of a structure uh, affect the suppression activities, and list some of the characteristics of some of the materials used in construction. And of course, maybe we will look at the 5 types of construction. And I'm sure by this time we'll be done with, we'll be on top of the hour because we have approximately 30 minutes to go. And that will be it. So we may not get to all of the objectives that are here, but I just hope that it will be a smooth ride. Well, how are these 3 people waiting to be admitted? Oh yeah, yeah. Yes, yes, yes. It's good now. Now it's just 2 in the waiting room. So building construction affects how fire grows and spreads. That is how the building is built. It will definitely have a bearing on how, if the fire would grow, how would it grow and how would it also spread. Firefighters need to, of course, understand how each of the types of building constructions react when exposed to the effects of heat. Uh, of course, this is also critical when we're thinking of how safe it is to enter a particular structure at what stage in fire development. When would it also be necessary to evacuate and leave the house? This is very critical for our safety. And there are these 3 key factors that I think and I feel would be important for us to maybe reflect on today. Um, first and foremost, the occupancy, then the contents of the building, and then the type of construction materials. Like I said, we are not going to build today. It's majorly going to be more of just learning some basics. So let's define these words. Occupancy. I wish I had some chance to just ask us what is occupancy, and we just think about it. Then what are the contents in this context of building and construction? Contents will mean what is in the structure, what is in the house. And of course, just like we are familiar with the various types of construction materials, what is a house made of? How does it affect its fire safety or fireproofness, etc. Now, occupancy. Occupancy is how a building is used. Just simple as that. How a building is used. For example, that's why in our government there is something called changing of user. Like you can change the use of a building, and by that you would also change the occupancy. It is about who is likely to be inside maybe that structure, maybe how many of such people, what kind of setup, and maybe what would they be doing at a particular time. Occupancy is what makes the difference. Like if you're in your station and you're on duty right now and a call comes in and you're notified on your call center that we have a fire in a high school, of course not during the holidays, during the school days, and it's a dormitory at maybe midnight. Now, what that means is that you will actually imagine the whole stack of students stuck in a dormitory with fire at night. It means they could be half asleep or sleepy. So they're in some sleepy stupor. It is pandemonic. And of course, this is also the difference that the same dormitory would be meaning something lesser to you if you had it was on fire, maybe at 1 o'clock in the day, on a weekday. In Kenya, most schools during the weekdays, the students will not be in the dormitory for the whole day time. So if you hear, for example, 11 o'clock, 11 a.m., that there is I think my internet is still misbehaving. Let me just change it. If you are informed, the internet, I guess this one is more reliable, so that I could have this. I'm doing okay. Yes. If you hear this, if you get the same notification that the file is there, um, um, okay, I don't know. Right here. The same dormitory at 7 o'clock during, maybe I'd like to do it this Wednesday. You'd imagine there is no students, a lot of difference. Is this the same thing if you hear that the government offices have a fire at night? Most likely there is no, except to be a fire station or police station, but the offices are vacant at night.
Alex, let me interrupt you for a second. Your screen is not sharing.
Really?
It says that you started screen sharing, but we're seeing a blank screen. And if you want, Ed or I can put up your PowerPoint and change the slides. That'll help you.
Yeah. We just try one more time. If it doesn't work,
Okay.
you right? Yeah. Let me see. Okay. Just a moment. Uh, um, All right. Coming right up. Uh, are we good?
No, we're still not seeing your screen.
Okay, maybe would call it can help, yes. Yes. Stop. Yeah.
Eh,
Ah, I see the problem.
Okay.
Okay. I know why. So we are almost there. Yes. So share the screen and here we go. Can you see it? We good?
We no, all we see, it says that you're started screen sharing, but we're not. Oh, there we go. Now we got it. You're back up and
Perfect.
running.
Wow. Just what I would want to hear, I guess. Uh, yep. Okay. So occupancy, back to this. Sorry for the time we spent on that. So I was saying that what we have to have in mind that what could be happening in the building or at any given time as firefighters. This part of building and construction that is really key. It changes a lot, especially in terms of rescue, public safety, and security. Who could be in the building when doing what? For example, if I know it's a factory and I know the operational hours, I know a particular part of the house, especially maybe the factory where people work from. Um, yeah, who could be there? How many of them would be there at a certain given time? What are the likely challenges they could be facing? Yeah. So occupancy is a very, very key point. That's why, especially for a working family, during the day, you can be sure in a residential house is sometimes likelihood that there are lesser occupants than during the night when maybe everyone is home. Yeah, that is occupancy. So moving swiftly to content, which is a key factor as well. Contents, uh, just as it is, content means what is contained in maybe the container that is the building now that we're talking about. What is in the building? Of course, there's a relationship between the contents of the house and the occupancy. Because, for example, if like we said, moving with the same example, like the dormitory of a school, if we have or a hostel, if it's a hostel, means that at the same time we have as many people, sorry, as many beds as are the likely occupants. Beds have lots of flammable material like mattresses, beddings, and clothes and other personal effects. So the contents of the building relate somehow to the occupancy. Just like if it's a commercial building that is having some, let's say, uh, it's a mattress warehouse. So we know they sell mattresses or tires, for example, or we would know that there's so many tires stuck up in the storage and the display area, and that is directly part of the fire load. We can guess the fire load of in the building, how much load of fire, and of course, even what are the properties of the fire, like how toxic could it be? Because there's that element of toxicity or the quality of the fire that is largely and directly dependent on what is burning. So what kind of smoke are we talking about? Now, so contents, what is in the building? Um, that's why it's necessary to know that on many structural fires, that is fire inside buildings, that we need to have our SCBA on because you never know what is burning sometimes. But actually, no smoke is good for your health. I think there is no day that anyone would prescribe for you some doses of smoke. But actually, sometimes some smoke could be even more lethal than others, depending on the content of the building. And that's why it's precautionary to, whatever it is, anytime indoors, to use our SCBA compulsorily without bargaining. So similar occupancies can pose different levels of risk. Also, depending on the volume. For example, in a residential house, um, just belonging to one family means there could be probably only 5 occupants at a go in a big house. But in a dormitory, a high school, maybe it's a residential, maybe same size, but could mean it's housing probably 40 students at a go, you see. So it's not just about occupancy, but what is inside the house? What's the volume of the load, the fire load, or flammable materials that are in the building? Uh, so undoubtedly, finally, before we go to the types of construction, that which is also critical for occupancy and contents. This can be informed part of your pre-incident planning, or maybe even when you receive a call, or if you do a good mapping of your area, you already know that this is probably the kind of occupancy for this kind of building, and maybe what are the likely contents. And it can inform your precautions and your contingency for the fire. It is so good for your, when you receive the call on your way, you can already think about it. But actually, the key thing is the type of construction materials. This will pose unique challenge to you, especially on conditions change time, especially exploring different kinds of construction materials, vary in strength. Some will be flammable, some are highly flammable than others are. Some will be safe, apparently, but the structure is weakened by 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 the heat. And we must learn actually to be good, maybe fire meteorologists. You can forecast that this is a house built of masonry construction, and so maybe after 30 minutes of this kind of fire, maybe this is the likely strength of the house. This is what could happen with this kind of roof. This could cave in, etc. So the properties of the materials that are used to build the houses determine the basic fire characteristics of the building itself. And I want us to think, for example, I don't know who is in the call, maybe mostly, of course, Howard and Ed are from the US. The rest could be from Kenya and maybe other countries. But maybe speaking to my fellow Kenyans, what are the popular construction materials used in our country? Think about it. Then have you thought about what could be the implications of course, these materials, in as much as fire behavior is concerned, or how, not really the how fire behaves, but how the particular construction and construction materials behave during the fire, you know? What are some of the property or factors on construction materials? One of them is combustibility. Combustibility, as you know, combustion is that process of the chemical process of fire, just the being of fire, and this is directly about Is the material used to construct the house flammable? Like, what is the building made of? And whatever it is, can it catch fire? In literal terms. Uh, in Swahili, someone will say, inaweza waka. Combustibility. Is it flammable? And secondly, thermal conductivity. Now, wait, when we're discussing combustibility, we are actually saying that if it's, for example, flammable, it means first the house is not fire resistant. It means that the fire will grow fast, not just from the contents of the house, but even the house itself will be actively participating in the fire. It means the fire will spread easily, and there will be a high level of compromise in the structure in a few minutes. It actually means that part of your salvage would not just be for the items in the house, but actually probably you need to save the building, to salvage the building. So combustibility is key. It means like the house, how the house is built, will it contribute to the fire that is happening or just be a victim of it? You know? So is, in other words, in the fire triangle, um, is the structure that has the structure of the house, is it part of the fuel for the fire that's happening inside? Um, the second one is thermal conductivity. Thermal conductivity is how easy does the material conduct heat. Maybe they are not having the combustion process, or maybe does it pass the heat across? And this has a bearing on to how easily the fire could spread. Because if the material is hot, it could ignite something that is flammable. Number two, your safety as you work with it. Like if part of your body would be exposed to the building, maybe the wall or something, could it burn you or could it affect your PPE, the fire hoses, or um, um, any other thing that you could have? Sometimes we're having a training in a fire simulator that's a container, a metallic container, like the one for it's the one that the ships use or the trailers. And it has some bearing that when I'm doing a drill in the container simulating a building, I have to be cautious of the wall because this time the wall is hot, it will directly be hot. Unlike if we are doing the same inside masonry construction, concrete construction, uh, you're almost sure that it will just be safe to even lean on the wall if there's no collapse yet. This time, in the container, you are very much aware that even the water that you splash on the walls of the building will vaporize into so easy that I could even vape back to you unnecessarily. Um, Another factor in construction materials is how does it react to heat? In other words, as definitely as the fire grows, the temperatures of the room are increasing. You have to be conscious of is the strength of the material changing? How rapidly is it changing? Because that means could we go in or not? What kind of risk is it to go into the building? This is a very critical factor to have. Another one is thermal expansion. Does the material expand when heated? So if, for example, some forms of metal, some metals maybe will have a high linear expansivity and exposed to heat, it means that definitely the structure will deform. The shape would morph into something. And that also directly changes the structural integrity of the building, changes it also means that if it's a combination of two types of material, compromise is high. For example, in reinforced concrete will have a steel inside. It still has high expansivity than the concrete. It means that when a pillar or a slab is exposed to high temperatures, there's a likelihood the concrete would crack because of how the material inside is behaving. Uh, of course, and the product of combustion, like if um, if we definitely have highly combustible construction material, for example, a wooden house, which is popular in yeah, uh, and some parts of even the county. Uh, what kind of smoke is coming from the construction material? Does it make me to have specific precautions? You see? Uh, so definitely on contents and construction materials, what kind of products of combustion? What are the qualities of the smoke that will come out of the fire, depending on the fuel? And this is on content to what is inside the building. Like, for example, a warehouse of mattresses will have what kind of smoke. Then this time it's a wooden house that is filled with um, they're both highly flammable, I guess. Flame. And I'm wondering how soon the structure will be consumed. I should think of what are the qualities of the smoke that we are having. And so maybe some of for about 10 minutes, we're going to just look at some of the common construction types in Kenya and abroad, I guess. We're just going to look into a few and maybe just some of the properties. And this is important for you to know so that as part of your size up, you're able to take the necessary precautions and also part of your actual fire suppression. If you have any question or if you would like us to pause and talk about something, you could definitely drop it on the chat. That will be very important. So, what are the common types of construction where we are? And one of them, this is the most popular in Kenya actually, is masonry. Masonry. That's why in Kenya the fundis. The fundi is the word we use to refer to the person who built the house. They are, in English, the name is mason, the masons. So when they build this, it's called a masonry construction. As you can see in the picture, will be some building blocks. They could be built from some rocks or bricks, beaten into shape, chiseled into good shape, or they could be extracted differently, different qualities of the bricks or blocks. Like on the picture here, we have on the lower side, we have blocks, maybe from some quarry. On the upper part of the picture, we have a different thing. It will be that will be some blocks and also bricks. Bricks means someone takes some form of soil or sand, then mixes it into something good. Then they have some casting, and they cast the stuff and mold it into a good shape for building. With all this together, the builder, who is the mason, makes some mortar. Mortar will be some mixture of building sand, special sand, and cement. I don't know what Howard and Ed call it in the country. So they mix the mortar is used to make some adhesion between the, the blocks or bricks. And that's the masonry construction. So the weak points are actually the mortar parts, but they're equally strong. In fact, if you build using weak bricks, sometimes the mortar, if done well, can be stronger. Now, this is inherently fire resistive because blocks and bricks are not flammable. They're also poor conductors of heat, high insulating properties. But if they have openings, the fire can spread through them because, of course, you can leave some openings depending on the pattern that someone is building, either for aesthetics or maybe towards the top of the building, next to the roof. There can be some spaces, especially after the ceiling. I'm not a mason, so I don't know how to call every kind of thing, but I guess we understand. Uh, of course, with prolonged exposure to fire, fire is so much destructive when it's prolonged and big, so that actually everything will lose its integrity in a fire, including masonry. But for masonry, it has to be prolonged to start to break down. Of course, this informs us that if you respond to a structure with masonry construction, unless if the fire has been for very long hours, the building is probably safe to enter if you need to. It also informs you that breaching it would be hard if you need to, for example, perform some forcible entry, which is not using the windows or doors. That means you would have to breach it using some smart techniques, including the shape of your entry point, think of how to disrupt the pattern safely. So if your windows and doors cannot be used for forcible entry, means you have to be heavily equipped and specifically trained and creative to make a breach through the wall. But nevertheless, as safe as it is from the fire, so it's also hard to breach, even using other means. This is the most common construction in Kenya today. Maybe it's many parts of Africa. It means therefore that our houses are fairly fire resistive from the construction material and the construction side, except for the roof, because we don't use masonry construction on the roof. We will see what material can be useful on the roof. Maybe looking at a couple more that are useful, that are hugely used in Kenya. Concrete. Concrete now is close to what we have in the mortar, except that we add some chippings. So there'll be the sand and the cement, and then we add some ballast. Ballast is small chippings of rock. I don't know, yeah. As you can see on the picture, because concrete takes time to dry up, it's first like some form of paste, liquid, thick stuff like porridge. And then also it is easily breachable. Mostly you have to reinforce it with some metal, mostly steel. As you can see, they have some steel structure, and then they're putting the concrete on it. And when you do this, the structure will be stronger than even more masonry. It is also more expensive. In Kenya, concrete is mostly used to build slabs in between the multi-level buildings. So in between the stories, we have concrete. Also for pillars, mostly the pillars. So it means that you'll be having sand, ballast, cement, and then inside will be steel, though you can see it. You cannot see the metal, but it's in there, somewhere in there. So naturally, this is fire resistive. It almost has the same characteristic as masonry. And it's a product of heat. They're still inside. So it's quite fit by the um, but it's in there. So with prolonged exposure, of course, there could be an uniform expansion. And though it's strong under compression, it can be weak under tension. This is how it withstands pressure and force, but tension is how it withstands pull apart. like expansion of the steel. So with explosive fire, it can be what they call spalling. Spalling means it's like it's breaking down like chow, like how wood starts to weaken and look like it's dust or something. So breaking into small particles. Especially of interest is that the metal inside, when it gets hot, it will actually expand and cause some weakness because there will be cracking of the concrete. Uh, Maybe we can look into one more that is common in Kenya. Actually, two, briefly. Steel and wood. Steel is actually strong material, but of course also quite expensive. Maybe that's why it's not widely used, except for those who live in containers. But
Hey, Alex, let me interrupt you for a second. Um,
yep,
Combination of the time and you're still having some issues with your coming across sound wise. Can you tie things up real quick so because it's been your quality of sound is good for a while and then it starts to break up. So if you could just tie things up, plus we're almost running out of time. Okay?
sure.
Thank you.
Yep. Yeah, yeah, yeah. Thanks, Howard. So still strong in compression and tension, but it's not fire resistive, and it's a very good conductor of heat. Um, that is steel. And Kenya mostly it's used in the industries and also for container. People use containers as storage materials or housing. I wanted to get to wood. This is still after burning, how it gets to misbehave. And uh, I want to think of wood, of course. Wood is very common building material. In Kenya, mostly we use it for the roof and sometimes for separation, like partitioning of the house. Wood is, of course, highly flammable. So if you call into a wooden house in approximately maybe a few minutes, the whole building could be coming down. Uh, the risk of survival by victims inside is very high, and also the contents. So we we could stop here, and I just wanted to consider that this is part of the information that you require when you are addressing a particular fire of a house or building. And the structure, of course, will invite particular challenges to you, depending on what is inside, who could be inside when, and what is the material it's used, the material used to build it. And this is a key for saving the lives and also the property, of course, the contents and the house itself. So I would like to stop there for today. I think it's a conversation that we can keep having. I have a few more slides I would share if we had maybe a longer time. But I just think you should have this in mind, and this will be critical in your decision making. Um, Maybe what would be the take home for today is find this to be something you always are concerned about. Don't just go into the building. Don't just fight the fire. Don't just spray water onto the building. Maybe think about it. Who's inside? Who could be inside? What is the house made of? What could change in 5 minutes of exposure to the fire? Is your water spray just extinguishing the fire or causing now contraction to maybe a highly compromised and expanded structure? What does that mean for you and your crew? So thank you very much. Would you have yourselves a nice evening? Those in Kenya, I guess. I don't know if Howard is about to take some, I don't know the time exactly. Maybe he's about to get to lunch or something. Um, Thank you. Thank you, Howard, for
Great.
hosting us. Colette for the support
Thank
and
you,
everyone for
Alex.
coming. Thank you. Yes.
Alex, it's a great presentation. Unfortunately, there was a little bit of sound stuff, but I think the not enough to sort of distract from the whole message of your session. Really important. I really appreciated how you highlighted that you just don't go running into the building. You just don't, you got to think about what's the building constructed of, what's in there, who's in there, what are the dangers around it. It's all part of that increasing our sense of our awareness on the scene. And that's what's so critical, not only for being an effective and efficient firefighter, but also for our safety and for the safety of any potential people still stuck in the building, in the space or around us. So great presentation. Thanks a lot. And I want to let everybody know I've posted several times in the chat links to other information you could get regarding the trainings that AFM is providing online and on YouTube and so forth. So make sure you check those out before you log off. You can always go to our website, AFM, just punch in AFM, AfricaFireMission.org, and it'll take you right to there, and you can get all this stuff, follow up. This presentation will be online in a little while. Might take a day or two because Mike is the one who puts those up, and he's currently in Kenya with the symposium. If you want to stick around, we're going to have tea time. Tea time is a chance to have informal conversation with one another about today's presentation or about anything else that's on your mind as a first responder. Don't feel free to stick around if you want. And on that note, I'm going to end the recording and bring this session to a close. And once again, though, I do want to say thank you all for committing some time. I hope that we proved it to be a useful time for you. We know time is valuable, as are your bundles. So thank you for attending. Thank you for doing what you do in your communities. And thank you, Alex, for your presentation, and Ed for sticking around. And on that note, I'm going to end the recording and officially end the session.